I'm going to skip number 4. This one's just the same as the other ones. I've got the graph there. I'm going to go on to number 5. This one's a little different, so let me do this one with you. So you know step number 1, you graph it at desmos.com. Find a clear 0 from the graph. So on the exam, what I'll do is I'll give you a snapshot of the graph because you can't go on the internet for your graphs. I'll give you a snapshot of the graph on the exam. So, all right, so where is a clear 0? Well, you can see right here, this is, well, it's a little bit harder to tell on this one. See how this one is halfway to -10? So this must be -5. I guess it's not totally clear, but pretty clear. You could focus in better than I did on the Desmos graph. You can hit the magnifying glass and increase the focus, and you'll be able to clearly see that it really is hitting 0 at -5. So x equals -5, the clear 0. Step 2, we divide now using synthetic division. So we'll put the -5 out there, and we take the coefficients as 1, 5, 1, 5. All right, and then we bring down the 1 and let the synthetic division begin. Multiply -5 times 1, -5, add them up, 0. Now, -5 times 0 is 0, add them up, 1. And then -5 multiplied by 1 is -5, add them up, 0. 0 remainder, that tells us indeed x equals -5, goes in evenly, so that must really be a 0 from the graph like we saw. Okay, so step 3, that gives us y equals, so what's left there? 1x squared plus 0x plus 1, and remember opposites would be x plus 5. So it's opposite when you put a single number next to x plus 5 there. Okay, opposite of -5. Okay, so now we go to the quad, our friend the quad. So -b plus or minus the square root of b squared minus 4ac all over 2a. Oops. I messed that up over there. Okay, so what do we got here? Negative, so here's a, b, c, so -b, -0, plus or minus square root of b squared, 0 squared, minus 4 times a times c all over 2a. It's going to be a little different here. So what do we got? Minus 0, that's just 0. There's no such thing as -0, it's just 0. Plus or minus the square root of 0 squared, 0. Minus 4 times 1 times 1 is just minus 4 over 2 times 1, 2. Okay, so what does that leave us? 0 plus or minus the square root of -4 over 2, right? 0 minus 4 is just -4. Now, what do we do with the square? What do we do with a negative number inside of a square root? Do you remember? When you have a negative number, you jump to the front and just right to the front of the square root. Don't let it go past the plus or minus or anywhere else. And by the way, that's 0. You can just get rid of it. It's not doing anything. So it's just plus or minus I square root of regular 4 over 2. Do you see that? So a negative inside of a square root, it means imaginary. You can't take the square root of a negative number. Like the square root of 4 is 2, of course, because 2 times 2 is 4. But what's the square root of -4? You can't do it. There's no real life number. What times itself is -4? How could you ever have, you can't have two negative numbers multiplying to be negative, two negatives multiply to be positive. The only way you could get a negative is one positive and one negative, and that's not the same number times itself. that's a number times its opposite. So there's no way to take the square root of a negative number. It's not real. It's not real. There's no real answer. It's imaginary. That's why when you have a negative in a root, we pop out an I. We take the negative out of the root and put an I right in front of the root. Because we're saying it's imaginary. It's not real. You can't do that. Okay, so where does that leave us now? So we bring this down to here. It's plus or minus I. Now what's the square root of 4? Just 2. And the root's gone. When you root something, the root vanishes. And then these 2's cancel. So this is just plus or minus I. So our answers are plus I, minus I, and the one we found from the beginning, bring that down, negative 5. Those are our 3 answers, which matches the answers they gave us. So what is that? What are these I thought these are the zeros, right? These are the zeros, which means the places where the function f of x or y, same thing, hits 0. Well, look at the graph. Here's the graph right here. It only hits 0 at negative 5. Nowhere else, right? Here's the line, the x-axis, that's at a height of 0. The only place this function hits at a height of 0, the only true 0, is at negative 5. It never touches the x-axis after that or before that. It never hits a height of 0 again, right? That's why the other 2 answers are not real. They're imaginary. It only hits it again in our imagination, not in reality. There's only one real 0. We call that the real 0. The one that is real life, it really hits at negative 5. The others are imaginary. It doesn't